Okay, so this one about the radio station fires is you should recognise as a negative binomial. So if we say we're using letter X as usual, it's going to come from a negative binomial, and we want 12 correct answers, and the probability of getting correct answer is 0.75. Right, so probability of our number of calls, so we want the probability of exactly 15 calls. So our number of calls is 15. Now you can use the formula book, which I've copied here. Here's your formula for your probability. Or you can also think about this logically. So what does that mean is going to happen? So the first 14 calls, we're going to have 11 people get the right, and 3 people get it wrong, but we don't care which order that happens is. And then what's going to happen is on the 15th call, they're going to get it correct. So 15th call correct, and then this is first 14 calls. Or as I say, you can do that with the formula. If you then work all that out, you get 0.180 to 3 significant figures. Okay, so in the second one, we want the probability there are more than 13 calls on the first day. So there's no upper limit there. We need to turn this one around. So that's going to be 1 minus the probability. There's 13 or fewer calls, but there's only actually 2 possibilities because the minimum number of calls is 12. So we take off the probability of getting 12 calls, and we take off the probability of getting 13 calls. So that's 1 minus the probability that all 12 callers were correct. Minus, and then if we've got 13 calls, we want 12 of them where 11 are correct and 1 is incorrect, times the fact that the last call, so the 13th caller is going to get it correct. And then once again, you just put that all into your calculator, and you should get 0.873 to 3 significant figures. Okay, so the last one's slightly different because now we're talking about the mean number of calls over 30 days. So we need to work out what the mean number of calls we generally expect is. Now this is handy to see the formula book. So the formula for the mean is this column. So that's R over P, where R is our minimum number, so our starting number. So this is negative binomial on R, etc. So 12 is our minimum number of calls. Our probability is 3/4 of getting a question correct. So that makes the mean 16. Now, the reason we're going to need this is because we're now talking about a mean number of calls. So we need to know the distribution of X bar. Now, remember by the central limit theorem that whatever the parent population, the distribution of the means is going to be normally distributed. Now this works for a large n, 30 in this case being considered sufficiently large, with the mean same as the population mean, and the variance is going to be the population variance divided by the sample size. So therefore we're also going to need to work out our population variance. So that's our variance for our negative binomial. So the formula again is in the book, that's this one here. So that's R times 1 minus P divided by P squared. If we work that out, that's 16 over 3. Okay, so our variance for our normal is 16 over 3 divided by 30. Okay. And what did we want to know? We want the probability that the mean number of calls is more than 15.5. So if we just think about our normal distribution, just to check what size of answer we're expecting. So the mean of the means is 16. 15.5 here's here, and we want this area, so it's going to be greater than half. But you can do this directly in your calculator by putting in your mean and variance, and if you do that, you get 0.822 for significant figures, and in the mark scheme you're allowed anything between 0.882 0.883, so that's fine. That's to allow for using tables versus calculators.